Hi everyone, in this video we are going to try and solve this exercise which is from chapter 4. So you have an electric field, okay, propagating in a lossless mediums, okay, and it is given by these formulas. So when we look at the electric field formulas, okay, we know that this is amplitude, right? This is amplitude, and because it is lossless mediums, so over here we don't have, all right, we don't have the exponent term. We don't have because it is a lossless mediums. And over here, over here we have the omega. Okay, so this is the omega, and this parameter will tell you that, okay, the wave propagate in the x directions and the electric field is in the y directions. Okay, so this is the informations that we have. So we are required to find the wavelength. So what is wavelength? Okay, the symbol of the wavelength is lambda. All right, so you can get this by referring to the relationship between the lambda, omega, and also beta, if you remember. So for this, it is easy. All right, so for questions A, lambda equals to 2 pi over beta. Okay, so the beta is here, 1.82. Okay, so we take 2 pi over beta is 1.82. Okay, so 2 pi over 1.82. So you have this 3.45. Okay, meter, because this is lambda. Okay, next is the propagation velocity. Okay, in your notes, we will see this propagation velocity or wave velocity represented by symbol of U. Okay, U. So when you see this propagation velocity, it means that you need to find the U. Okay, so we apply this formula whereby the U is equals to omega over beta. Okay, so it's 10 power 8 and the beta is 1.82. Okay, 1.82. So you 10 power 8 over 1.82. Okay, is 54.95 mega meter per second. Okay, meter per second is the unit of speed or velocity. Okay, right. So dielectric constant, C, right? The dielectric constant means that they're asking you to find the epsilon R if the relative permeability is equals to 1. Okay, so they are asking you this. Okay, you can refer to the formulas for the calculation of beta for lossless mediums. Okay, for lossless medium, the alpha is equals to 0. Okay, but the beta, you can calculate it by using this formula. Okay, omega square root, okay, mu naught, epsilon naught, and epsilon r. Okay, try to find this formula in the notes. Okay, so omega is 10 power 8. Right, 10 power 8. So beta is 1.82. Right. Okay, so over here you will put mu naught, epsilon naught. Okay, because the mu r is equals to 1, that's why we don't put anything here. So our target is this epsilon r. Okay, epsilon r. So let's calculate this by taking this, divide with 10 power 8 equals to square root mu naught, epsilon naught, and epsilon r. Okay, so if I want to remove the square root, I have to square both sides. So 1.82 divide 10 power 8, and then the answer I square it. Okay, it's very small, 3.312. times 10 power negative 16 equals to mu naught, epsilon naught, and epsilon r. Right, so I will divide it with the mu naught. Okay, so your epsilon r will be equals to 29.77. Okay, so this is how you find the epsilon r. Alright, next, find the magnetic field. Okay, when the x is 1 and the time is 1 nanosecond. Okay, so the question give you the equation of electric field, but they didn't give you the equations of magnetic field. So you have to find out yourself. So your magnetic field will be something like this. You will have an amplitude, right? Amplitude. Okay, it is still cos, right? And here will be 10 power 8 t. Okay, because they are propagating in the x directions. Okay, so x directions over here is it 1.82? Yeah, okay, x directions, and the h directions you need to find out. Okay, so you need to find out what is the amplitude and you need to find out what is the directions. Okay, we go for this direction first. Okay, so we apply this relationship. Okay, we have applied this relationship many times. Okay, so the electric field directions, you can refer to the formula, okay, which is Y. Okay, right, H is something that you want to know, and the K is referring to the direction of the wave propagating. So it is X directions. Okay, so over here we know that our H will be equals to positive Z. Okay, your magnetic field will be pointing in the Z directions. All right, regarding the amplitude, okay, so the amplitude of the electric field divided with the amplitude of the magnetic field will be equals, okay, will be equals to the eta. Okay, what is eta? Eta is the intrinsic impedance. Right, so we have no idea what is this intrinsic impedance, but we can calculate it by using these formulas. Okay, so this is the intrinsic impedance for lossless medium. Okay, for lossless medium, you are going to use this formula. Okay, lossless mediums. Okay, so we know that our mu r is equals to 1, right? And this is mu naught, and divide with the value of the epsilon r that we find just now. Okay, 29.77 multiply with epsilon naught. Okay, so this is equals to 1. Okay, so you can calculate this. So divide so it is equal to 69.05. This is the intrinsic impedance. Okay, so the electric field has the amplitude of 200. So H is the amplitude of the magnetic field that we want to calculate. And the eta, we replace with 69.05. So the H is equals to 200 divide 69.05. Okay, and it is equals to 2.896. Right, okay, so this is the amplitude. Okay, so now let me write down the formula. So is 2.896 cos 10 power 8 t minus 1.82 x, and in the z directions. Okay, so we have got the formulas of magnetic field, and now we want to find the value when the time equals to 1 nanosecond. All right, and the x is equals to 1. Okay, so we can replace the value 2.896 cos, okay, let us simplify this. 10 power 8 nano is negative 9 minus 1.82. Okay, so I have negative 1.72. Okay, exact. Okay, make sure you are in the radian mode. So cos the answer and multiply 2.896 is equal to minus 0.43. Okay, ampere per meter. Ampere per meter. Okay, so this is the magnetic field value. Okay, at the time 1 nanosecond and also at the position x equals to 1. Alright.